In this video, we're going to take a look at how to check to see where a graph is increasing and decreasing by using the increasing and decreasing test. And then we're also going to use the first derivative test to see where a maximum and a minimum occur on a graph as well. So to start, let's take a look at this graph here where we have a function f, and we have the points a, b, c, and d on that interval, where a is less than b, which is less than c, which is less than d. So I'm going to mark these points on this graph here. So if f prime of x is greater than 0, so remember that f prime is another way to say our slope. So if our slope is greater than 0 on an interval, then f is increasing on that interval. So this means that the graph goes up from the left to the right. Now on our graph, this would be from point A to point B. If f prime of x is less than 0 on an interval, so that means that this time our slope is negative, then we say that our f is decreasing on that interval. And this means that the graph this time goes down from left to right. So notice we always talk about left to the right side. Okay, finally, if f prime of x is equal to 0 on the interval, saying that this time our slope equals 0, then we say that f is constant on that interval, and this means that the graph is flat. Oh, so when it has a negative slope, that would be from b to c. So let's write this down. I forgot the example. And then an example of where it's flat would be from c to d. So I'm going to show you the steps to find the intervals algebraically now. So we're going to set up a sign chart for f prime of x using the critical points. Remember that the critical points occur where f prime of x is equal to 0, but also where f prime of x is undefined. So that will happen when we have 0 in the denominator, for example. So these are going to be breakpoints in which the graph could possibly change directions. All right, so actually what I'm going to do is I'm going to follow the steps, but do an example as we do this. So we're going to use A as our example. So it says, use a sign chart for f prime. So first I need to find f prime of x. So that's going to be 2x plus 2. So we set this equal to 0. And I'm going to solve by factoring. So here x equals -1. So I set up my sign chart. I'm going to place -1. It's my only critical number on my sign chart. And then it says, on each interval determined by the critical point, so we have a left and a right side of -1, we're going to pick a point at random, and we're going to plug it in to f prime of x. So to remind me, I'm going to put f prime of x here. So I'm going to pick f of -2, and then I'm also going to pick f of 0. All right, so we're going to plug this in. So when I put -2 into my equation here, I'm going to get a negative value. If I put 0 into this equation here, where it says f prime of x, I get +2. So I'm going to have a positive number. So here it now says, if a point gives a positive value, then you know that f prime of x is positive on the interval, which it is, and hence that the function increases. So we're going to show that with a plus sign above, and then I'm going to draw an arrow to show that it's moving upward. Likewise, if a point gives a negative value for f prime of x, such as when I put in -2, then we know that f prime of x is negative, and hence that the function now decreases. So we put a negative sign like I did here, and then we're going to draw a downward sloping arrow. And this will help me later when I do some graphing too. All right, so to summarize, it says find the intervals. So the interval where it's decreasing is x is less than or equal to -1. Now we put an equal to because we do include the endpoints. I guess it's because it's continuous there, okay? So we want to put the equal sign. And it says justify your answer. So I'm going to put because f prime of x is less than 0, or slope is less than 0. And then it's going to be increasing when x is greater or equal to -1. And this time because f prime of x is greater than 0. So again, we still include and put an equal sign at -1, even though you can see that it's increasing and decreasing on both -1s. But this is the convention that we use. All right, so now let's go on to the first derivative test. So the first derivative test uses f prime of x to classify whether a critical point is a maximum or minimum. So the first derivative test, so how it works is that suppose we have c, and it's a critical number on a continuous function. And let's draw a graph to show this. So we'll put this over here. So we have f prime, and this changes from a positive, so we can see this is positive slope, and then we have a negative slope. So at this point C here at the top, so f prime is positive on the left side and negative on the right, then we say that f has a local maximum. Now we can have a curve that looks like this. We can also have a cusp. So this would be our point C, and we can see that our slope is still positive on the left side and still negative on the right side. If f prime changes from negative to positive at C, then f has a local minimum this time. So a graph would be something that looks like this. So let's say we have this point C here. This time we can see that our slope on the left is negative, and on the right our slope is positive. And we can also have corners too. So we have C here, so f prime is less than 0, and then f prime is greater than 0. Okay, so finally, if f prime does not change sign at C, then f has no local maximum or minimum. Now you might think, oh, that's really obvious because we can have a flat line. But we have some other examples that I can show you too. So we can have a curve that looks like this. Okay, so here at C, the slope is greater than 0. And then on the right of C, the slope is still greater than 0. We can even have some piecewise function that looks like this. So here at C, on the left, we have f prime is less than 0, and still on the right side, f prime is less than 0. So by drawing a schematic picture, which means that we're going to do a sign chart with upward and downward lines, then you remove the need to memorize the test. So you don't really need to memorize it, but if you draw a sign chart, you can tell whether it is a maximum. So let's take a look at an example. So let's locate any extreme values of f for x cubed minus 12x minus 5. So our first thing is we're going to find the first derivative. So we get 3x squared minus 12, set it equal to 0, and I'm going to do some factoring. All right, so now we see that x equals 2 or negative 2. So I'm going to now draw my sign chart. And I'm going to plug these numbers into the first derivative because we want to know what the slope is. So when I plug in negative 3, let's say, and I plug it into f prime here, I am going to get a positive value. And this is going to be increasing. Plug in 0 into here, I can see I get a negative value. And I draw a downward arrow. Plug in 3 into here, again, we get a positive value. So I'm going to draw a positive and an upward arrow. So here, just even looking at the arrows, I can see that this goes up and this comes down and this goes up again. So that means here we have a local max, and here we have a local min. I don't know if it's the greatest or the largest or the absolute max or min because I haven't done any more testing, but what I'm interested in right now is just to find out that it's a maximum or a minimum value. So now we can say that there's a local max at x equals -2, and we'll actually plug it in now. So the maximum, when I find this, I plug in -2. Now remember, I'm plugging it into my original function to find out what that y value is. And when I plug in -2 into the function here, I get 11. We have a local minimum at x equals +2, and then that minimum, when I plug it into my original function, is -21.